Welcome to The Explainer. Today, we're jumping right into the deep end, the high-stakes world of emergency toxicology. We're going to break down the playbook doctors use when they're racing against the clock to solve a poisoning. All right, so picture this. A patient is wheeled in, they're fading fast, and you have absolutely no clue what they took. This isn't some TV show, right? This is a real, everyday nightmare for ER docs. So, where do you even begin? Well, the answer might actually surprise you. It's simple, but it is so critical. The number one rule: forget about the poison. At least for a minute. You have to treat the patient, not the poison. And that all starts with the ABCs. And listen, this is way more than just a first aid thing you hear about. This is the absolute bedrock of emergency medicine. We're talking airway clear? Check. Breathing? Check. Circulation, meaning pulse and blood pressure? Check. You've got to lock these things down before you even think about an antidote. It's all about keeping them alive, right here, right now. Okay, so once the patient's stable, that's when the game completely changes. The fire is out, for now. And this is where the doctors switch gears. They go from lifesavers to full-on detectives. The hunt is on. But this is the real puzzle, isn't it? I mean, how on earth do you narrow it down when there are thousands of potential culprits? We're talking everything from drain cleaner to some super obscure toxin. What's so cool about this is that they don't just start guessing. No way. They have a system. And that system revolves around a really clever mnemonic, SYNCAM. What's brilliant about it is that it doesn't care about the poison's fancy chemical name. Nope. It classifies them by how they attack the body. Is it a corrosive, just demolishing tissue? An irritant, causing a massive inflammatory reaction? A neurotoxin, messing with the brain? This simple framework cuts right through the chaos and tells the team exactly what part of the body is in the crosshairs. All right, let's do a quick run-through of these 6 categories. It'll really show you what these doctors are dealing with. So first up, you've got the demolition crew, corrosives. These are the nasty ones, like strong acids or alkalis that literally just destroy tissue when they touch it. You know, stuff like sulfuric acid. But here's a really important catch. They're not all the same. And this is why it matters so much what kind of corrosive it is. See, alkalis, they're usually way more dangerous. Acids cause what's known as coagulative necrosis. It basically creates a hard scab-like barrier that can actually stop the burn from going deeper. But alkalis, they cause liquefactive necrosis, and that is just as bad as it sounds. They literally turn tissue into a soupy mess, which lets the poison just keep burning deeper and deeper. The damage is, well, it's catastrophic. Okay, next on the list are the irritants. Think of these as the agitators. Their whole goal is to cause massive inflammation. And this category is huge. It covers everything from heavy metals like arsenic to plant toxins like what you'd find in castor beans, all the way to things like snake venom. Then you have the neurotoxins. I like to call these the signal jammers. Their target is the body's main computer, the brain and the spinal cord. And they can go one of 2 ways. They can be depressants, you know, like alcohol or opioids, that just slow everything down to a crawl. Or they can be stimulants, like cocaine, that just crank the system into absolute overdrive. Now for the cardiotoxic poisons, literally the heartbreakers. These guys skip everything else and go straight for the heart muscle. Things you might even have heard of, like digitalis, read and nicotine, can mess with the heart's rhythm in a really bad way, causing arrhythmias or even straight-up cardiac arrest. Next up, the asphyxiants, the oxygen thieves. Now, some of these are pretty straightforward, like carbon dioxide, which just pushes the oxygen out of the way. But others are much sneakier. Take carbon monoxide. It literally hijacks your red blood cells so they can't carry oxygen. And then there's cyanide, which is maybe the worst of all. It doesn't stop oxygen from getting to your cells. It stops your cells from being able to use that oxygen. It's truly terrifying. And last, we have the miscellaneous bucket. And this is a really important one, because it's a huge reminder that the biggest dangers aren't always some rare, exotic poison. A lot of the time, they're the things we have right in our own homes. We're talking toilet cleaners, bug sprays, nail polish remover, even gasoline. The threat is often hiding in plain sight. All right, so knowing your enemy is half the battle, right? Now let's get into the other half, the counterattack. How do the doctors actually fight back once they've got a lead? Well, just like identifying the poison, the response has its own playbook. It's a 4-step process. Step 1, stabilize the patient. That's our ABCs again. Step 2,
Stop the body from absorbing any more of the poison. Step 3. Help the body get rid of what's already in there. And step 4, the final move, if there's a specific antidote, you give it.
So that second step, preventing absorption, that's where you might see something you've probably heard of, gastric lavage. Basically, stomach pumping. It works best if you can do it within an hour or so. But, and this is a huge but, it is not always the answer.
In fact, sometimes it can make things a million times worse. Think about it. If someone swallowed a corrosive and you try to pump it back out, you could literally tear a hole in their stomach or esophagus. Or with something like kerosene, if they breathe any of it in during the procedure, it can cause a deadly chemical pneumonia. This is exactly why identifying the type of poison first is so incredibly important. But what about for things like heavy metal poisoning? Well, for that, medicine has this incredible tool in its arsenal. They're called chelating agents. You can think of them as metal grabbers.
And here you can see some of the big ones. Things like BAL, that's short for British anti-Lewisite, and EDTA. These things are amazing. They're basically molecular claws that go hunting through the body for toxic metals like lead or arsenic. When they find them, they grab on super tight, forming a totally new, non-toxic package that the body can just safely get rid of. It's honestly such an elegant and life-saving bit of chemistry. So when you see it all laid out, the first moments of stabilization, the detective work to identify the threat, and then the super targeted treatments, you really start to see how this whole process takes an absolutely chaotic, terrifying situation and turns it into a clear, structured plan. And that really is the key takeaway. It's all about the system. The ABCs buy you time. The SYNCAM mnemonic brings order to the chaos. And then the specific treatments, like those chelating agents, fight the battle at a microscopic level. It's this playbook, this step-by-step approach, that turns a potential tragedy into a story of survival.
You know, it's a powerful thought, isn't it? In a world that's full of hidden threats, maybe the best antidote isn't something you find in a vial at all. Maybe it's knowledge. Which kind of makes you think, right? What other dangers are hiding in plain sight that we're just not seeing?